Hello and welcome to another episode of a Wicked Parley. Tonight, as you probably guessed from the thumbnail, we're talking about the cosmos. And this time it'll be more entertaining, hopefully. Yeah, so obviously during the last Cosmic Queries, we had a whole bunch of questions that we didn't quite get to. And honestly, I look forward to being able to address a lot more, and hopefully in a little bit more detail and a little more enthusiasm than perhaps... Yeah, oh my god. We're gonna break my ears! Oh my lord! Anyways, so without further ado, we're going to jump into it, but we're going to begin with a few definitions. And Rose, would you be cool enough to throw up the first of the definitions we're going to be covering?
Yeah, of course. Happy to do so.
Okay, so if we're going to talk about, life, we're going to talk about planets, we're going to talk about stuff, we need to at least acknowledge the Drake equation. Now, the Drake equation, I could go into all the details, and if you want to pause the video and look at the particular equation, then you can. But the general gist of it is it's an equation that's trying to calculate the likelihood of intelligent civilizations in the universe, like what that number might be. Obviously, that number is at least one, depending upon who you ask. I mean, I like to think humans are intelligent, so yeah. But I mean, some people would say maybe not, because, reasons. So yeah, that's the gist behind the Drake equation. If anyone has any questions about it, feel free to email the show. But yeah, just kind of something to kind of throw out there. And then we have another equation that's related to the Drake equation that if you mind throwing up there, Rose, and that's called the Fermi. Well, Fermi paradox is an element of the Drake equation, not quite an equation in and of itself. And essentially, the Fermi paradox, in its simplicity, is trying to answer the question of, if there is alien life in the universe, where are they? That's the gist behind the paradox, and there's a whole bunch of reasons why that might be. And once again, if you'd like to hear us discuss this, email the show. We'll be happy to answer any questions you might have. But yeah, that's the gist of it. So we have a few more definitions for you.
Yeah, we got 3 more.
All right. Want to throw up the next definition?
Yeah, and this time I won't scream.
Oh, fine. I will. Yeah!
There we go.
We get one scream in.
One scream per person.
Yeah, why not?
All right, the next one is a star.
Ooh, star.
In our case, a self-luminous gaseous spheroidal celestial body of great mass which produces energy by means of nuclear fusion reactions. And I looked at spheroidal and I'm like, spheroid, I get. Spheroidal, no.
Yeah, and also I just want to say this now. If you have an elderly parent or grandparent, the gas that they produce is not qualifications for a star, no matter how smelly it is. Nuclear fusion is not going on no matter what you say. Alright, let's go to the next definition.
Yeah. Next up is star system.
Star
We're going for the astronomy one, people. We're going for the astronomy.
Yeah, are you sure? We talk about, famous actresses. I mean, like, oh my god, didn't you know? I mean, like, what about Nick Cage?
No.
Oh, come on, Nick Cage.
No, we're talking about
Nick
astronomy.
Cage. Fine, astronomy.
A group of celestial bodies that are associated as a result of natural laws.
Okay, natural laws.
For the film industry, that's a bunch of man-made laws.
Hey, man is natural, so is it not also a natural law?
We have to make it ourselves.
Still natural.
I mean, so are the machine. I mean, we make the machinery too, so.
I did not argue that.
That's not exactly natural.
Well, who's to say what's natural and what's not?
Yeah, that'll be a topic for another thing.
Sure. Okay. Next definition.
Terraform.
Ooh, terraform. I love terraforming.
To alter the environment of a celestial body, in parentheses, in order to make it capable of supporting terrestrial life forms.
Pop quiz. What is...
I don't like quizzes.
Okay, fine. When do you think the first instance of terraforming occurred? Nope, there is no wrong answer.
The first thing of terraforming?
Yeah, what do you think is the first example of terraforming? Actually, let's preface this by saying, first of all, do you think terraforming has happened already?
Like, if you're just altering the environment, then just anything that, like, makes a home or makes a nest because you're altering the area around you, right?
Yeah, that's right. So
like it's
so
not
how long?
just man-made.
Yeah, it's not just man-made. Yeah, exactly. Something that makes terrestrial life forms possible. So the key part of this is terrestrial life forms, meaning that something that's living on a planetary body doesn't have to be necessarily on its surface. When do you think that the first instance of this particular thing happening occurred? Like, just ballpark it.
I don't have an exact time frame, but I'm gonna assume just the first like actual land animal.
Interesting. Okay. What if I were to, talk about something that maybe existed 2.5 billion years ago?
I mean, I wouldn't know.
You wouldn't know? Oh, okay.
I'm not that old.
Are you sure about that? Are you sure?
I'm pretty sure.
You sure about that?
I'm pretty sure. Yeah. Or is it the dementia talking?
Some of the dementia talking. Some of the earliest crustaceans that utilized shells to essentially alter the way in which they moved around and kind of lived their lives could be examples of terraforming, because they used their shells to manipulate the actual environment they were in to make it more suitable for them.
Yeah.
So, yeah, I mean, like, terraforming is kind of like a weird thing because it has so many different ways of going about it. I personally go back to some of the earliest life forms that would manipulate the terrain to their advantage and to better their survival. And that would be my definition, and that's why I'm okay with this. But you could easily say terraforming, perhaps when we started altering the climate, like by pumping in all sorts of gases about 150, 170 years ago, something like that. We could be also talking about terraforming. But yeah, terraforming has definitely occurred.
Different stages of terraforming.
Yes. So, anyways, also very important for talking points. So, cool stuff. That way you guys know where we all stand with these particular definitions as we delve into the cosmos. So, I just gotta say, I'm super excited to talk about this particular subject.
We can tell.
It's not because of the wonderful Dutch brothers that's right here, that's almost nearly gone, but I actually also really love talking about the stars. And the last time we talked about cosmic queries, it was like, I don't want to talk about the beginning stuff. I want to talk about the cool stuff.
Talk about the cool stuff, but sometimes the beginning stuff is some of the cool stuff.
Yeah, it is. I mean, it totally is. So, let's jump into it with the first section, which was going to be just questions surrounding planets.
Yeah. So, first and foremost, speaking of beginnings here, how are planets created or formed? Okay. Whatever word you want to use for it.
I either work. So the gist behind planetary formation is still somewhat of a mystery. However, thanks to computer modeling and some very good theories, we have some pretty darn good ideas about how that process works. The basic one, the one that which most people subscribe to, is the idea that when a star is forming, typically this is like imagine like a gaseous area that likely was the leftovers of a supernova explosion of a very massive star. Yeah. Enough of the materials coalesce into a smaller star. That star, through gravitation, actually attracts other of the material that is in the same general vicinity, and it creates a kind of plane, like a flat disk-like area that orbits around this newly formed protostar. Well, that material, over time, coalesces eventually into worlds, and those are usually form hundreds, if not thousands, of micro worlds that sweep out an orbital plane around this protostar. When the protostar ignites and becomes a full-fledged star, it will kick off some of the material and kind of push it out into the outer system, or even completely out of the system altogether, depending upon the level of force. And depending on the size of the star, the density, the mass, the material, all those things are variables that decide just how far that material goes. So, yeah, caveats, Anyways, those materials then, once those small worlds start to, essentially go around and coalesce, they eventually collide with one another, and you start seeing kind of like a survival of the fittest, or there could only be one in this particular part of the system. And depending upon the chemical makeup of those worlds often dictates winners. Now, typically, if you have a gas giant, it's probably going to devour all the worlds that are immediately around it.
Nom nom.
Yeah, just because usually they're so big and dense by that point.
All right.
But yeah, I mean, that's the general gist behind it. I mean, there's a few other forms of them as well, but we can delve into those a little bit later.
Yeah, sure. So, of course, there are like water planets, terrestrial planets, gas giants, and whatnot. So what actually determines their composition? Do they like take whatever's closest, or
That's kind of a tricky question because it kind of depends upon the material that the star essentially is comprised of. Some star systems are rich with hydrogen and water and things like that, and so you could say the chemical composition of most of the world is going to have whatever element is most featured in that system as their core building blocks.
Okay.
As an example, in our system, water, carbon, silica stuffs, metals, those seem to be fairly common to the point where we have at least 4 fairly large terrestrial worlds, and then the various moons around some of the gas giants and ice giants seem to also be comprised of water and metals and carbons. So you could say that our system was rich in those. But there is absolutely no reason why you could have anything on the periodic table form technically a planet, assuming you had sufficient quantities of it.
So it's usually whatever's the most abundant.
Yeah, and typically speaking, like when a star blows up, right? It's the best way to kind of think of a star is like an onion, right? And as you go deeper on each layer of the onion, it's composed of a completely different element. And when the star explodes, it sends that material in all directions, kind of like if you imagine buckshot from a shotgun. and
explosion everywhere.
Yeah, and so you're gonna have pockets of more dense material in different areas, and so depending on where that star forms depends on what pocket receives the most amount of material around star formation. And so you could easily have a section that's maybe comprised mostly of hydrogen, and you'll get a really big gas giant maybe, or maybe you'll get a lot of like metals like iron and other things, and just then that will be what you have a giant iron planet. Probably not entirely composed of iron, but its core certainly would be.
Sounds like Treasure Planet.
Kind of.
Just with the metal planet.
Hey, maybe even with the rings. I mean, that could happen.
Maybe.
Yeah. So it's determined kind of based on what's in the area. What can they gobble up?
Pac-Man.
Waka 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 waka.
Makes me question. Like, are there planets with more hollow cores?
Oh yeah. The moon, although not a planet, is a celestial body, and technically speaking, almost all planets are celestial bodies. It's all about orbital stuff. Anyway.
Yeah.
So when two bodies collide, it's thought that whatever the more massive object, it kind of rips the core out of that particular world. And so sometimes some worlds can have 2 cores. Earth is one such world. We have a nickel iron core.
Okay.
And so we actually kind of have the benefit of this, but the moon, for instance, is hollow. Like if you were to hit it, it rings like a bell. And in fact, when the
how the heck do we know that?
When the Apollo missions landed on the moon, scientists were able to measure a vibration that was the ringing of the lunar lander impacting the surface, and it was radiating across the entire sphere of the moon.
Oh, that would do it.
Yeah, it was like this.
You don't exactly get that with the solid.
Yeah, I mean, it's not exactly like oh my god. Like, I always think of it like the moon kind of like a big giant lava rock. How there's like all these pockets and holes.
Porous?
Yeah, it's very porous. The whole moon is very porous. So I think of the moon's core probably as like a honeycomb. And there might be a small core there, but like whatever is there is much smaller and not nearly as active as Earth is.
No, I'm just thinking of it like a rock sponge, just with all the little holes.
Yeah, that's probably it. Imagine a rock sponge covered in dust. That's pretty much the moon.
Got it.
It's so weird.
Yeah, it's a little weird because I just started thinking of like other things. Like I immediately thought of a sponge covered in dust, and I'm like, that's not clean.
Yeah, it's not clean, and that's the reason why. Like, I don't know if you've ever seen pictures of like the astronaut suits, but they're covered in lunar dust. Like literally covered.
Sounds very
stuff.
sparkly.
Yeah. Well, if smoke color is sparkly, I guess
Yeah, it's sparkly enough.
Okay.
Anyway.
Sure. Let's go.
Okay, so that's what determines compositions. All right.
Yeah, that's the thing.
So, what about distance between the orbit of whatever celestial body and then the thing they're orbiting around? What determines that? Is it like gathering up a bunch of material and then just staying in it, or for a car analogy, staying in its lane?
Yeah, that's a little bit more difficult to actually specify. I can give kind of like a rough answer for it, but like just know that it's very variable, and there's a lot of information out there that suggests that the idea I'm going to put forth isn't entirely accurate.
I mean, that's why it's variable, right?
Yeah, it's very subjective at the very least. So the first idea is to consider is tidal interactions, right?
Okay.
And tidal interactions happen by other celestial bodies basically orbiting close to another body, and it causes that particular body to stretch, so that they get tugged in different directions.
Okay.
Those particular kind of tugs interact with their star, and so like you got two different planetary bodies tugging on the thing from different angles, and then you got the star that's holding it kind of in place as it kind of falls around it, right? Mm-hmm. And so what ends up deciding whether or not like where a planet is going to necessarily lie has to do with those interactions. And that's also probably the reason why a lot of worlds collide early on, is because can you imagine having thousands of different bodies constantly tugging on one another? It'd be like literally like a pool table, and someone just hitting the pool cue ball like all over the place and shooting them all in different directions and bouncing all over the place.
That sounds like one way to shoot one out of the table.
Oh, for sure. In fact, it definitely happens sometimes. So like it's not uncommon, but that kind of like that it's an ultimately like a last man standing situation, where you got a whole bunch of different planetary bodies essentially gravitating towards one another and yanking and pulling until eventually the pathway for them is cleared to such an extent that they're the only thing sitting in that overall plane, and then it just kind of depends on the overall gravitation of the star which they're around, or multiple stars, that dictates the exact path. Also, other celestial bodies can interact with those worlds and change the orbit over time. Like if a particularly massive object comes flinging through a solar system, it can actually shift the orbital pathways of worlds and change where they normally would be, and sometimes can even do the horrible thing of ripping it out of the system and then taking it with it. Like you imagine like a dense star getting close to another star, it can sometimes yank a planet out of its orbit and take it along with it.
Just planet napped something.
Yeah.
It just went yoink.
Yes, it can yoink.
Okay then.
Indeed. So, was there any more questions about planets that you had?
Just really one that kind of goes into the next section too, actually.
Okay, fun.
So let me go ahead and just start. Hey. Mm-hmm. So, when it comes to colonizing planets such as Mars.
Okay.
Ta-da.
Mars.
I sometimes hear the question of why don't we pour that energy into making our planet habitable? Like, what do you have to say to that?
I mean, that's an understandable position to someone who doesn't 100% understand what goes on regularly. When it comes to the development of technologies and exploring other worlds. The first place that any technology that would be used is usually tested here on Earth. And through the testing process, it's kind of sort of like you get a sample for what it can do here. A lot of the things that are speculated about how we could change hypothetically Mars by steering, say, comets or other icy bodies into its surface to build an ocean has been speculated at different things in which we could do to protect the Earth from such collisions. And so a lot of the technologies that go into the development of potentially terraforming another body have also been considered for different applications for Earth, whether it be for protection, whether it be for modifications and things like that. I mean, the idea of just getting something really big and cold and just kind of dunking it in the ocean, kind of like a Futurama episode of a big ice cube. I mean...
Just yeet a glacier into the...
Yeah, I mean, it sounds crazy, right?
Yeah.
But, like, it was considered, and it wouldn't do anything, really.
Oh.
Well, it wouldn't do enough. It's not that it wouldn't do anything. It just wouldn't do enough to change things. And I think that we do send a large number of satellites into space to observe worlds. One of the biggest number of satellites actually orbits the Earth and gives us information every day on different things. So I'd say that the energy that's being put forth in attempting to potentially understand how we could go about terraforming other worlds also is being used on Earth to help better our understanding of how we might be able to assist Earth today. And in fact, our understanding in the 90s about the ozone layer and the dangers of certain chemicals that were being used that was destroying the ozone layer was only found because of the technologies that we were using to scan other worlds. And so you could argue that the technology that helped essentially stem off the destruction of the ozone layer was directly responsible, was directly developed at least through the technologies that were intended to explore other worlds.
Okay, so it's just a very happy byproduct.
Yeah, I would say that it's more like you test what you got, at home before you actually travel, billions of miles to go test it somewhere else. And so, like, if there's a positive byproduct, it's going to be, it's going to be experienced and used. So I would say that likely any positives that come from that particular line of research also affect the Earth. And they probably affect the Earth before it affects the other world. So,
I mean, you need to travel there first. So.
Yeah, it's a little difficult, to be like...
It's a little difficult.
We're going to launch this prototype, and we're going to wait and see about 2 or 3 years. And then we'll get back to you. Or we can, test it tomorrow and find out if it works or not. It's like, I don't know.
Yeah, what do you want to do? The ultimate procrastination project.
I mean, that's just going out of your way to procrastinate at that point. You're just going out of your way.
It's like, alrighty then.
Yeah.
Ah. All right. So what's the...
So the next subject that we're going into is talking about star systems, right?
Yeah.
All right. Star systems.
So I had this question a little while ago for the first episode, actually. So if two star systems ever kind of get relatively close to one another, what happens? Do they collide? Do they combine? Do they repel each other? Do they go boom?
Yes. So, obviously we have a picture that we have collected sort of on there that actually answers that question to some extent. And so the gist behind what happens is, let me explain the picture first, and then I'll explain the other part of your answer. We'll do it kind of backwards. Sorry, guys. So in this particular picture, the first image on the left showcases a star that is passing close to another star. That star has at least a very large planetary body, and that's because we know this because in the second image of the shot, you actually see a shadowy image next to that very bright star passing by. And it's passing by to such an extent that's actually blocking some of the light from that star. And then in the last image, you actually see that star has now collided with that particular celestial body and has darkened the surface of that star, probably due to its material. And the likelihood of that particular planet being a gas giant, I think, is pretty darn high, considering the fact that to block out the surface light off a star is no small feat, and it would require a mass amount of material to do what's being depicted. Yeah, because they had to shoot it in ultraviolet and in X-rays in order to actually make out the full image, because it actually blinked out. Like you couldn't see it for a bit.
I was about to say, what got murdered on screen?
Yeah, it's called a celestial body. A big gas giant probably got eaten as it passed as two stars passed too close to one another. And so kind of was like, and gone.
And bye.
Yeah. In essence, to answer your question originally, a whole bunch of catastrophic things can happen. The first one is that you can have, of course, planets, as we kind of discussed before, get ripped away from their home systems.
Yeah.
And the other thing that can happen in very rare circumstances is the two stars can actually collide with one another, and it creates a supernova.
Yeah.
And that, of course, would be that's curtains for the both solar systems that might be part of that star systems. And so, yeah, I mean, like, there's a whole bunch of things that can happen. I think the biggest one, the most common one to see, is probably a disruption in the orbital paths of the planets. Typically speaking, space is pretty big. And so even if a star got really close to another star, it's probably the gravitational effect of the star being close that's going to disrupt the orbital pathways, the ellipses, essentially, of the planetary orbits the most. They're not going to actually collide with anything. They're just going to be like really kind of wonky orbits. And that's something we see all over the place in the universe. I mean, quite literally, like our system, the fact that for the most part, okay, we're not talking about everything, but for the most part, all the planets more or less follow the same orbital ellipse. They're all in the same plane, more or less, with a few exceptions. Looking at you, Pluto, Neptune, and some of the inner planetesimals. Some of them orbit like this. Like they orbit in weird ways.
Alrighty.
But yeah, or like a weird like X pathway, which is kind of strange. Actually, I did a horrible thing on my hands there. I wish I had like a dry erase board behind me. I'm like, and this is the pathway it takes. But we don't have that.
We'll think about it.
Yeah, for a future episode, look forward to me using terrible drawing in Chicken Scratch. So.
Sounds like a normal professor.
Ow, burn my soul. Anyways, so that's pretty much the gist behind your question for the most part. There is a couple little small caveats that can happen, which is kind of unique a little bit. If those planets ever had like asteroids or comets that kind of followed them, that were precessional sort of thing, like where like after like 50 or 60 years, something like that, or maybe like 100,000 years, whatever, those kind of really elongated orbits. When you have two stars that are essentially in close proximity, those orbits decay and they just get kind of like shot off into space.
Bye.
So when two planetary bodies get close, anything that's in the outer fringes kind of gets kicked off. So.
Okay. That kind of answers my next question, actually, which was pretty much how do bodies, get thrown out of or pulled into different star systems? And you've mentioned it's things messing with the orbital system.
Yeah, honestly, when a pretty big body enters close enough to another world, that's pretty much the end of I would say a consistent, peaceful orbital existence and beginning of chaos.
More peace for you, buddy.
Yeah. Honestly, like that's probably where we're at. Do we have any questions at this point when it comes to the chat?
No.
No? Okay.
There hasn't been anything in the chat.
All right. Well, anyone who's watching or in the future, if you want to like throw a question out there in the comment section or want to throw one in the chat, feel free. I'm totally happy to answer any questions you might have.
Would be absolutely thrilled to talk more about space.
You don't have no idea. I love space. I love a good mystery out there, right? Space is awesome. So, anyways.
So if you love a good mystery, what are some theories that people have about star systems? Which, just list a couple that you think have merit, and then list a couple that you think might be just pure fiction.
Okay, sure.
And then I have a surprise one after.
Okay, cool. All right. Okay, so what I think when it comes to theories is that I think is pretty credible is actually the discussion of our own solar system and the discussion about how Neptune and Uranus formed. What a lot of people probably understand is that both these worlds are blue, but they might not understand why they're blue. They're blue because they're comprised primarily of hydrogen, helium, and water. Now, it might be strange for you to think that there's anything weird with that particular notion, considering that most people in classes are taught that the gas giants formed out in the outer system because that's where the gases were. Well, actually, that's not where the gases were at the beginning of the system, and so it's a little weird that the pathways of the gas giants and ice giants are where they are today. It does, however, make sense that some gas giants might be failed stars, because often stars form in groups. And so what gas giants might be are failed stars. And so that might explain both Jupiter and Saturn. But that doesn't explain Uranus or Neptune. And there's a theory that says that Uranus and Neptune actually formed in the inner system, closer to where Venus and Earth are today. And that perhaps either Earth and Venus and Mars and Mercury and perhaps some other worlds were either much further out, or they were moons of Uranus and Neptune. And that at some point in the history, Jupiter and Saturn tugged on Uranus and Neptune and dragged them from the inner system and hurled them out of the system. But because of gravitational effects, they were slowed and stopped to where they currently are today by the gravitational effect of both also Jupiter and Saturn and the Sun. And that's a theory that I've heard many times that kind of explains the composition of the worlds in a way that kind of makes sense. The evidence to support that is not the best, but it's not so bad that it's unthinkable. It's more like the modeling to get that to happen is a little bit tricky, but not impossible. That's the key thing. Another theory that I've heard that I absolutely think is ridiculous is the...
So that's one you think is more fictional?
Yes, I think it's more fictional. Is the idea of a nemesis. Now,
what?
Nemesis is supposed to account for a gravitational disturbance that was detected about 20 years ago.
Okay.
That explains the reason why the orbital pathway of some of the trans-Neptunian objects are ever so very shifted a little bit, because they don't quite make a perfect circle or even close. They kind of have weird wonky orbits. And there was an idea that was put forth that there must be a secret brown dwarf star about 20,000 Over 20 million kilometers, something like that. Like
The Great Brown Dwarf.
some crazy number that puts it like outside of the visible range.
Yeah.
Of our telescopes, but but not so far that like it's in between the stars. It's still in the system. It's just really far out.
Okay.
And there's been no evidence of this thing other than the theory. And the theory it sounded good. Like on paper, it sounded smart. But then like when they went to go look for it, they couldn't find anything for it. And you'd think that like the Voyagers, considering where each of the Voyager paths are, they would have detected something by now, considering that one of them has passed through the heliopause, the other has passed through the heliosheath, which are like the outer sections of the solar system. And they've traveled much further than where this thing probably had to have been for it to actually have the effects that the model suggests. And so that's kind of like one of those weird ones. It's like, that's probably not right. I mean, I also be the first person to be like, that's fucking wrong. And put my shoe in my mouth and be like, oops, I guess I was wrong. But like, no, honestly, Nemesis, probably not real. However, there's one more that I'll say.
What up?
That's kind of like an in-between. It's kind of like, it's plausible, but it also is kind of in the kooky camp. And that's the idea of a Planet X. Or like a true Planet 9 or Planet X, depending on however you want to call it. The theory of a Planet X started when Pluto was still technically a planet. So like that's why the name Planet X is thing. But they also talk about being a Planet 9 since Pluto got demoted. And
For Pluto.
Yeah,
Viva la Pluto.
Yeah. And so if you remember the first theory I had about the whole idea that Neptune and Uranus got kicked out of the system.
Yeah.
Well, there's an idea that there's another ice giant out there.
Ooh.
That's a little bit smaller than Neptune and Uranus. Not by much, but it orbits kind of further out. And that it has a really, really long orbital period. And so it gets so every like 20,000 years or so, it gets really close to the sun. And then it kind of goes out again for about another 20 to 30,000 years.
Yeah.
And it's like really, really far out there.
Uh-huh.
Kind of like a Hale-Bopp, but like on a 10 times magnitude. And that might explain the Nemesis thing, but like not be Nemesis, if that makes sense.
Kinda.
And it kind of would also get, if it was proven to be true, then it would give credence to the whole idea of Uranus and Neptune being starting closer into the system and then being kicked out.
Huh. Yeah. Alrighty then.
Yeah. So.
Do you have time for the surprise question?
Heck yeah, let's go with a surprise question. I like a surprise question.
Surprise question.
Yeah, surprise
What is a theory you've heard that completely sounds fictional, but you would love to be real?
Ooh, that is a good question. Okay, I mean, it has to be space oriented, of course, right?
Yeah.
Okay. Alien time machine.
Alien
time machine.
Oh, yeah?
Okay, so it was theorized that if you were to focus enough energy into a single point, you'd be able to warp spacetime into a loop. So that way, whenever you started that particular energy, anything going essentially into the portal could travel at any point from when you began to however long the portal's been active.
Huh.
And the idea that maybe an alien civilization out there somewhere created a time machine or created this portal-like effect, right? Yeah. And let's say it's been around for like 1 billion years, right? Then we could go into it and travel back 1 billion years in time.
We just have to get to it.
Yeah, exactly. And also find it. And have had a civilization, be smart enough, early enough to be able to create it. And it would probably be a superstructure. A superstructure meaning that you'd have to be like a type 3 or better civilization to do it. And without going into too much details, a Type 1 system, solar system, well, Type 1 civilization, has the ability to control 100% all of the energy that their planet produces. A Type 2 civilization has the ability to control and manipulate all the energy that their solar system produces. And a Type 3 civilization has the ability to control all the energy that is produced in their galaxy.
Wow.
And so in order to produce the type of energy required to generate something like that and keep it sustained for that long, you would have to have control over something like a supermassive black hole. Something that had almost unthinkable levels of energy and the ability to be almost perpetual. So it's in the realm of science fiction. I mean, it's on the absolute cliff note, like the lightest side of plausibility.
It's improbable, but it could be possible.
Yeah, it is,
just because it is that
yeah,
big of a universe.
Yeah, it's the probability of it is so minute that it's almost unthinkable. But it's just that, I mean, I put it like this. I would say that the odds of that existing are more likely than me winning the lottery. But saying that does not say very much. Although some people say I'm very lucky, so maybe like they're like, oh, actually, this says quite a lot. But that's, I don't know.
Yeah, it depends. Depends on what you're lucky in.
Yeah, I mean, yeah, that's true. I mean, oh my God, Genshin. Oh my God. I'll tell you later. I'll tell you later. It's hilarious.
Yeah, sure. Anyway.
Yeah. So.
But yeah, that was a surprise question.
Ooh, yeah, love surprise. So, are we any more questions about solar systems?
Not from me and not from the chat.
Okay, well then let's talk about the next area of subject: galaxies.
Yeah,
love galaxies. Galaxies. So, like, before we get into any questions, I gotta ask you this.
Sure. What?
And also, there's a question to the chat too, as much as it is to Rose. Do you have a favorite galaxy, and why?
I don't. I only know the names of 2 galaxies, like ours and Andromeda. I think that's one. Or is that just a star system?
No. Andromeda is the closest galaxy.
Yeah, I only know the names of 2 of them. But if I had to choose one, if you just gave me a list of names and then what they looked like, I'd probably go for whatever one would have the prettiest shape.
Okay, all right. So does color can figure into this at all, or?
Color probably not. Just like with the picture that's on right now, it's like that looks pretty.
Okay, all right, okay.
So yeah. It's like the shape would determine it.
Okay. For me, there's 2 galaxies that I like quite a lot. I like Triangulum, and I like the Sombrero Galaxy.
Did you just say a Sombrero Galaxy?
Yeah, the Sombrero Galaxy.
What the heck is that?
It literally looks like a sombrero. I'm not kidding. God. You should look it up sometime. It's hilarious. Okay, anyways, the reason why the Sombrero Galaxy is something I like is because it's a galaxy that is made up of some of the oldest stars in the known universe. It's actually literally slowly fading out. It's winking out of existence. And it looks like an incredibly thin disk of light. It's so freaking cool looking. I love it. Right. Yeah. And then the Triangulum Galaxy is it's like a pseudo spiral galaxy. It's got the pinwheel effect almost, so it's almost like a pinwheel galaxy, but not quite. And it looks really pretty.
Alrighty then. At the moment, we don't have anything in the chat, but I'll let you know.
Yeah. Okay.
Yeah. So starting off with what may or may not be a basic question. I don't know. We'll see we'll see whether it's basic or not once I read it. So when it comes to the different star systems inside of a galaxy, is it considered part of the galaxy just because it's based on proximity, or are there similarities between it and the other star systems?
To be honest, I don't know the actual answer 100%.
What do you speculate?
I would speculate that it has to do... spectate. I'm just going to watch this. I would speculate that it's likely has to do with its proximity to the rest of the stars. That I'm not sure. I don't think... I would think... All right, now this is just me guessing here, all right? Yeah. But I would think that it'd be really difficult to prove that this star came from anywhere else. Just considering how long most stars live, the idea of traveling the distances of intergalactic space and going from one galaxy to the next would be a little tricky, to say the least.
No, but I'm just saying, what if they have a galaxy inside of a galaxy, like we have a city inside of a country, like we have a country inside of a city inside of a country?
So this part I can actually answer. Did you know the Milky Way galaxy is a monster?
Huh?
It's a monster. It eats other galaxies.
Oh.
Yeah, there's a whole bunch of things. There's the Magellanic. So there's the Magellanic Clouds, right? These are what they call satellite galaxies. They're basically if our galaxy wasn't enormous, right? Then these satellite galaxies would actually be full-fledged galaxies. But because they're so small in comparison to ours, they are satellite galaxies, and the Milky Way is slowly incorporating them into itself.
Huh.
Yeah.
So technically, we already have mini galaxies inside of our galaxy.
Yeah, in fact,
Okay.
you could probably say that most galaxies are a collection of other galaxies that have just been essentially absorbed and melded into one another. Typically speaking, there's multiple different types of galaxies that exist, such as spiral, whirlpool, globulus, disk. Each one indicates a different age of the galaxy. Typically, most galaxies that start off probably as globulous galaxies, that slowly over time, as they rotate, eventually become spiral galaxies. And then I would imagine very likely, and this is also sort of guesswork to some extent, that spiral galaxies eventually, as they absorb others, start to become pinwheel galaxies as the material is unevenly absorbed into the galaxy. And then over enough time, eventually will become kind of like a disk, similar to the sombrero galaxy. And unless another galaxy comes along and eats it up. An example of this, for people who are going to be excited about this, is in about roughly 1.5 billion years from now, the lovely Andromeda galaxy is an even bigger monster. It's an even bigger galaxy than ours, and it's coming for us.
Oh.
It's coming to eat us, and it's going to will become the Milky Andromeda galaxy at some point. There's a fancy name for it in the future.
Right,
whatever.
that sounds like they got married and they're trying to decide which one gets hyphenated.
Yeah, I guess. So this image right here is kind of like a picture of what they think Milky Way kind of looks like. It's okay, you don't need to pause on it. But it's also a very good, decent image of Andromeda as well.
Okay.
Andromeda is just like this big, giant pinwheel galaxy.
Yeah, I like those pinwheels. Those are some of my favorites.
And it's thought that basically it's going to collide. And the interesting thing is that in the collision, either the solar system is going to get kicked out of the galaxy, right? Get yeeted out, or it's going to get pulled into the core, or it's going to get thrown into one of the arms. Those are the only three things that could happen.
Oh.
And so we have a 33.33% chance of being sucked into a black hole, 33.33% chance of being sucked into intergalactic space, and 33.3% chance of landing in some giant colossal arm full of other stars. But it won't really matter because everyone on Earth will be fucking dead. And they'll be dead because the planet will no longer be habitable by that particular point.
Oh my god.
So fret not, people out there. It won't fucking matter. Although the show of it coming in is going to be one of the most magnificent things. I mean, if I had the ability to have a time machine, it would be one of the main things I would want to travel to the future to see. Because roughly about 100,000 years and up until the moment of collision, you're just going to see the Andromeda galaxy get closer, 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 closer.
God, it just sounds like that one meme video with the cat.
Yeah.
Where you peek around the corner and then the pet's there. Peek back, and it's closer.
Yeah.
Go back, peek around, closer, and then it just pounces.
Yeah, that's exactly kind of what it'll be like, but on the sky. And so what will be really cool is on certain nights you'll see the Milky Way galaxy band right through the sky, and then as a cross across it, you'll see a galaxy slowly getting closer and closer and closer.
Oh, lovely.
Yeah, and let's just hope to God that we're on the side that is away from the collision, because that's the one that's the most greatest chance of being put into one of the arms. If we're on the collision side, all right, the space is so huge that stars will pass right by one another. So we're not going to have... the odds of it getting hit with the world is very, very low. But being ripped out of the system, though, is also very, very, very high. And also Andromeda is chock full of black holes. There's a lot of them. It's something so in the Milky Way galaxy, it's speculated that roughly about every 1,000 light years, there's one black hole. Distributed throughout the Milky Way. That's a rough estimate, but that's the gist, right? In Andromeda, it's something like one is in about every 250. So it's about 3/4 times more common.
Well.
So.
Alrighty then.
Yeah, it's kind of
So. Moving on from death and destruction.
It's not death and destruction. It's called creation. Okay, Rose? It's creation. This is very important. You don't have creation without death and destruction. You have to break some eggs in order to make an omelet. Don't forever forget that. I love that analogy. It's one of my favorite analogies.
Now I'm hungry.
I know. I've had coffee. My appetite's suppressed, but I'm there.
All right. So, onto a more light topic, I suppose.
Okay.
How do we determine things about galaxies like size, age, other factors, and stuff like that?
A fun question, and a question that is kind of a mixed answer.
Okay.
So when it comes to the size, we first detect the luminosity of the galaxy. The reason why the Milky Way galaxy is kind of an enigma is because we're inside it, we have a really hard time measuring it accurately. We can only measure sections of it at a time, depending on where we're at. So, if people keep up science and measurements, about 50,000 years, we'll have a pretty good idea of the Milky Way galaxy. But it takes about that long because we can only map out with any real good detail the section that we're immediately in. So as we orbit around, we'll get a clearer picture, section by section by section by section.
Okay.
So that's kind of, and we need to go through 2 orbital periods in order to collect sufficient data, because you'd have to get the first one to get the idea, and then to double check the data is correct, you have to make another orbit. So I guess you could say we have a good guess in about 20,000 years, and will be confirmed in about 50. So,
all right.
So anyways, so that's one measurement. The other measurement, when you look at like galaxies on the outside, is you calculate like a combination of luminosity in comparison to other objects, because how bright something is not necessarily indicative of how old it is. It just is how indicative of how energetic it is, and depending on the different form of energy that's being produced and being able to create the luminosity dictates a whole bunch of things and variables. An example of this is that, you're not going to count a supernova explosion as, oh, that star's bright today, and it went away 2 weeks. What happened to it? He's like, oh, well, I guess that system is no longer as bright. It must be older. It's like, that's not a real accurate way to measure things. So you have to take into consideration a whole bunch of different things, but that's one of them. The biggest clue to the age of a galaxy is the general composition of the vast majority of the stars that are in it. So if you have a series of, let's say, soul-like stars, like our home sun, then I would say that your galaxy is probably middle-aged. But if you have a whole bunch of, let's say, highly energetic, very big stars, things that would be constantly in nova state, maybe there's every 100,000 years or so, you're having the star blow up and create a whole bunch of new stars. So you can see a lot of star formation is existing a lot in that system. Then it's a relatively young system. And then if you have a solar system, a set of solar systems that are comprising of worlds that have a lot of, let's say, red and brown dwarf stars, and the galaxies are kind of faint, it means that most of the stars have stopped producing other stars, and you could say almost that star formation has now ceased. And when those stars go, there won't be new ones to replace them, and so that system is probably very old. And so those are some of the things they're used. Of course, that's not a 100% accurate way to measure something. There are a whole lot of other things that they measure. Black holes, for instance, can be looked at to indicate to some extent the age. And there's a great anomaly of a galaxy that seems to be older than the universe, based upon this particular type of calculation. So something's not accurate, and it's hard to pin down what it is. Now, I have a couple theories, but they're just theories.
It's just a space theory.
I know, right? Just a space theory.
God, I love game theory.
Game theory's great.
Yeah, it is. Okay, that's... All right, more detail than I thought.
Okay. What were you expecting? Me just to kind of gloss over it?
I don't know, maybe.
Oh, wow. Oh, my God.
I said, I don't know.
It's okay. It's fine. It's not fine, guys.
So is it because of the, attraction and the pull of the stars that keeps galaxies together rather than, having them fling apart immediately or something?
We're going into that, are we?
Yeah, we are going into that. That's next.
Okay.
Of course we're going into it.
Yeah, okay, all right, okay.
Yeah.
So the answer to that question is no one really knows. Yeah. So
another speculation question.
Yeah, a while back, astronomers were trying to understand, essentially, or to better account for all of the material in the universe. And they started checking the precession rates of galaxies, i.e. the rotation of a galaxy, right? And they were trying to take that particular number and then compare it to the expansion of the universe. So that way they could get an understanding of kind of like how much material is probably there. And in their math, it showed that if their math was correct, which, you know, for all intents and purposes, it probably was, the galaxy would literally fling itself apart because there wasn't enough gravitation there to hold it in place.
Okay.
And so they created this wonderful concept that is called dark matter. And it is a fudge mechanic number that they insert into their equation to account for the lack of gravitation that prevents these worlds from spiraling into oblivion. And no one really truly understands what's going on there, like at all, still. There are instruments that have been designed to try and find dark matter and also dark energy, which I may or may not discuss in a little bit, that have mixed results when it comes to their findings. Some people say that they found it. Other people have tried to repeat the experiments and have found that they couldn't find it, while others said that they repeated it and also found it. So the results are inconclusive at this time. I'm under the speculation, and this is super me guessing here, that dark matter doesn't exist. That there is an element of gravitation that makes it not actually exist at all. That it is some sort of attraction force between bodies that is easy for us to call gravity because, you know, if you use Newtonian physics, you know, to explain the universe, then gravity is really easy to calculate for. And so, like, if you're sending a spaceship, you know, around the sun or to a body, then it works. But the moment you start getting on larger scales or near really dense objects or black holes, then it all kind of falls apart. And I think that's because we don't really have a firm understanding of the very small and the very large, and having that bridge of explanation to describe both natural orders. And it stems primarily from the idea that in the discussion of the very large, the universe is curved. You know, it's a sphere. And in the universe of the very small, space is flat. And obviously, these both can't be correct. And so something has to give. And I suspect that the very large, although I don't want it to be proven incorrect, and probably is. It seems very likely at this point because the issues stem there. They don't stem from the very small. So sadly, Einstein fudged up somewhere along the way. And people have carried the torch ever since. And so we're running into the problem of today. When it comes to what keeps them together, it's their own material, their own mass, alongside a supermassive black hole, and then an unknown energetic quantity that has been quantified as dark matter. To sum up the question.
Okay. That's all I really had for galaxies.
Okay.
Ooh.
Fun stuff. Fun stuff. All right. Let's talk about black holes now.
Sure.
We were going to discuss this. Hopefully, we'll just address maybe one or two black hole questions, and then we'll jump to the other questions for what we have.
Yeah. Just let me know the number.
Actually, you just pick them. I don't mind. Whichever ones jump at you as the most interesting. And then we can address the other questions we had at the very end.
Sure. Oh, here's one. So, let me get time. Alright. What might happen if two or multiple black holes are in close proximity to each other? What happens?
The larger one eats the other one.
Is that it?
In essence, yeah. What ends up happening is that they slowly orbit one another. And the one that has the more mass essentially starts to absorb the accretion disk of the smaller black hole, eventually absorbing it all. And then when the accretion disk is absorbed, the gravitational effects of the two black holes start to merge, and the larger one basically devours the smaller one. You think of it like two giant...
boring than I imagined.
Yeah, you can imagine like two giant whirlpools that have, astronomically large amounts of material getting closer and closer and closer and closer and closer until eventually the one that's larger starts to skim the smaller one off, until eventually all that remains is just its core, and then eventually they merge and the larger one engulfs the other. And the even crazier part is that eventually that black hole will eventually get eaten by an even larger black hole at some point in the universe. And then eventually, when all the black holes have eaten all of each other, and the only thing that's left is one giant supermassive black hole, it will eventually evaporate.
Pardon?
Yeah. The death of the universe ends with all the material in the universe being absorbed by a series of black holes that eventually gobble up each other. And then eventually, all that's left is one very large, very hungry black hole that eventually will dissipate into nothing.
Oh.
And then the universe will be empty. Minus some Hawking radiation that may exist.
What?
Yeah.
Hey.
I know, it's totally weird, right?
It just goes poof.
That is what all the mathematics that talks about black holes suggests.
So, like, is there anything... I mean, this is part of another question.
Well, go for it. Ask the question. Go for it.
Like, if the last thing in the universe is just the black hole, and the black hole is going to go poof eventually.
Yes.
What's after? Is there anything after? Like, can anything come back, or is it just gone?
Well, that is for philosophers to decide.
Well,
actually, I'll put it this way. A sufficiently advanced civilization might be able to create a pocket of subspace. So a dimensionality existence in some ways to survive the end of the universe, I guess, and find some way of using other universes to feed energy from, and then either jump to that other universe or take material to start our own and perpetuate our own universe's existence artificially somehow. I think that that's probably not realistic. And I just think it's not realistic because even if our species evolves, adapts, changes, whatever, if we continue on, if we don't get wiped out by a large asteroid or have stupid leaders nuke us into oblivion,
Christ,
like if somehow we make it past some sort of cosmic bottleneck and we actually get to a point where we have control on a galactic scale, we're a multi-planetary species, we're going to run into a couple of different problems pretty early on, but way before we have to deal with any of this sorts of crap. The first thing we'll run into is the breakdown of the genome. So there's an actual upper limit for the number of times in which we can essentially, procreate before we start having serious genetic defects. And those genetic defects will eventually end the species as all species end. That's if you are successful, that's how the species ends. You essentially breed to the point where you can no longer breed. And humanity is actually reaching that particular position a lot faster than I think a lot of people realize. About 375,000 generations from now, we'll have reached that limit. Which sounds like an incredibly long time period, but realistically speaking, that's not that far away. I mean, that's a little over 1 billion years. And then we're done. Kaputz. That's it, folks.
Bye.
That's all she wrote without some sort of artificial genetic engineering. Now you might say, okay, with that much time, we'll have figured it out and we'll have made it. And I will say that's possible. That's entirely possible.
Maybe.
I think what's far more likely is that we're going to find a way to transfer consciousness into an artificial body, whether it be biological or mechanical, and eventually humanity's consciousness will just exist in that form, and we won't have biological bodies anymore. And so I think that the idea for human will just kind of go away, or at least the idea.
It sounds like an interesting mini topic.
It could be a mini topic. I mean, it's something that could be discussed. But yeah, anyways, back to black hole stuff.
Yes.
A sufficiently advanced civilization could create a pocket dimension and feed energy. It could utilize Hawking radiation and coalesce it into the creation of perhaps a galaxy or so. Maybe. But even that has maybe that even has its limits because, the heat death of the universe is a thing. It'll eventually become so cold that nothing can exist. That literally the structures by which, like the oscillation of atoms that creates warmth, will cease. So even that won't be a functional thing. So there's so many elements of things that we would need to compensate for that the universe that we all take for granted, that the universe just kind of does for free, that we'd have to start addressing. And at that point, we're kind of be playing God. To some extent, and so I wonder on the viability of something like that. It also, to me, adds an extra layer of speculation that makes me think of Are we in a simulation? Is there a god? That sort of thing. So, yeah. Although totally off topic from black holes. So sorry about that.
I mean, it's a pretty big topic, which gets into the
Yeah.
philosophical at some points.
There are elements, that's for sure.
Like the whole, what happens after the black hole disappears? Don't talk to me about that.
That's the heat death of the universe. That's what's actually after. And that's exactly what happens after.
Boom, boom, bye.
Yeah.
All right. Anything else you want to talk about?
We should get to a few of those questions that we had at the very end.
You mean this one?
No, but okay. We can go that one.
Like,
yeah, it's fine.
Oops. Because if you're talking about this one, I just asked.
Oh yeah, I already know that. I know that.
Yeah.
We'll go with the ending question.
Okay.
All right. So, after hearing about all these interesting things about the cosmos, and we mentioned the Fermi paradox early on, the Fermi paradox, which of course indicated the question of if there's aliens out there, where are they? My question to you guys, the viewers, is where do you think the number is in the Fermi paradox? Do you think that the number of intelligent civilizations is greater than 1 by a lot or a little? Leave that in the comments section below, and we'll look forward to seeing you guys in the next one. Saturday will be a fun episode, guys, so hopefully you guys will have a good time, and will tune in. Until then, have a good night, everybody. Later.